Hello guys, today we will be looking at the 2021 UKMT IMC paper. This is a 1-hour paper with 25 questions. First 15 questions are worth 5 marks and the last 10 questions are worth 6 marks. And obviously the first 15 questions are relatively easier compared to the last 10 questions. So without further ado, let's get straight into it. Alright, question number 1. This is a very simple arithmetic question, so all we need to do is, let's just do it in our heads. 2021 plus 2425 minus 2223 is 4426 minus 2223. 4446 minus 2223, which gives us 2223. So 1 is B. Let me just write it a bit lower. 1 is B. Alright, question number 2. Question number 2 is actually a very tricky question because there's too much information. And let's just start with it. So day before yesterday was 2 days after the day before my birthday. Today is Thursday, and what day was my birthday? So let's first evaluate what was the day before yesterday. If today is Thursday, the day before yesterday was Monday. So the first part is Monday, and Monday was 2 days after the day before my birthday. So that's 1 day after my birthday is Monday, so my birthday was on Sunday. As I told you, a pretty tricky question, which requires you to read properly. Question number 3, 2 minus 4 minus 2 so 2, that gives us 6 minus 2 equals 4. 3 is C. Question number 4. This is actually a pretty tricky question. I won't draw it out, but let me just quickly tell you the logic behind this question. So as you can see, you might instinctively go for drawing the line perpendicular to the side PQ, which would go through V and X, but this is actually not true. There is no such line that crosses V and X. We don't know whether it actually crosses V and X, so we can't assume that. Rather, we can actually look at the heptagon PUVWXYQ. In this heptagon, the sum of the angles is 900 because n minus 2 into 180 is the sum of angles in an n-sided polygon. And we know all the angles except angle VWX. So we can find that out by subtracting them from 900. So what we do know is UPQ is 90. So we have 900 minus 90. And the other angle YQP is also 90. Then we have XYQ, which is 74, PUV, which is 62, and we also know the obtuse angle, the reflex angle UVW, because that's 360 minus 90, 270, and similarly WXY is also 270. So we are left with VWX, which is equal to the sum, which is 820 minus 90, 810 minus 90 is 720, minus 540 is 180 minus 74 minus 62, which is equal to 44 degrees. Although this would give you the same answer had you drawn a straight line, we cannot assume there is a straight line, so we actually have to work it out this way. So 4 is still A, but that's a wrong approach if you went to draw a straight line. Alright, question number 5. Question number 5 is such that 3 people have sweets, and the total number of their sweets is 90, and May has 3/4 the amount of sweets June has, and April has 2/3 the amount of sweet May has. How many sweets does June have? Alright. So let's assume June has X sweets. If June has X sweets, May has 3/4 X, and then since April has 2/3 of her, she has 2/4 X. The sum of this is equal to 90. 9/4 X is 90. So x is equal to 40. So June starts with 40 sweets. Question number 6. Kai has begun to list the factors of 240. The positive integers which are not factors of 240. What is the 6th number on his list? So if you didn't know this, 240 actually has a lot of factors. Just an interesting fact. So let's start listing the non-factors of 240 like Kai. Alright. So 1 is a factor, 2 is a factor, 3, 4, 5, 6 are all factors. First non-factor is 7. 8 is a factor, 9 is not a factor, 10 is a factor, 11 is not, 12 is a factor, 13 is not a factor, 14 is not a factor, 15 and 16 both are factors. However, 17 is not a factor, and that is the 6th number on our list, so 6 is E. Question number 7. Question number 7 is a very simple question. If you do realize that you cannot leave 4 minus a quarter in a mixed fraction, you have to leave it as an improper fraction, and 2 minus a half has to also be left as an improper fraction. This is equal to 15 over 4 into 2 over 3, which is equal to 5 into 2 over 4, which is 5 over 2, which is 2.5, which is option C. Question 8. Question 8 is actually a pretty simple question. So, in question 8, you have to realize to use Pythagoras' theorem. When given a rectangle, what is the one thing we know for sure? We know that the angles are 90 degrees. And in this particular rectangle, we actually also know the side lengths of this rectangle. This is 10, this is 14, and M is over here, and O is over here. So, what we already know is we can create this triangle with this being 90 degrees, and we can find the length MO, or OM. Doesn't really matter. So, first let's find the length. Let's say this point is A. We first need to find the length OA. So the length OA will be from the center of O till the end of the first rectangle, which would be length 7, because the whole thing is 14. Half that, you get 7, and half of the length of this, the width of this thing would be 5. So OA is 12. Now we need to get MA. MA is the whole thing, 14 minus half of this length, because O is in the center of this and 14 is the total. So 14 minus the O to this point, which would be 5, giving us 9 over here. And then you can apply Pythagoras' theorem to get 12 squared plus 9 squared equals OM squared. 225 is equal to OM squared, and OM is equal to plus minus Siri just popped up. Alright, since you can't have negative 15, it must be plus 15, so 8 is B. Question number 9. Question 9. How many of the following statements are true? A prime multiplied by a prime is always a prime. That obviously can't be true because a prime has no factors other than 1 in itself. So the first one is not true. A square multiplied by square is always a square. That's true because let's say we have two numbers, a squared and b squared. If you multiply it together, they give you a squared b squared, which is ab whole squared. So that is true. That's the first true statement. An odd number multiplied by an odd number is always odd. That is also true. We can prove that, but let's just take a case, for example, 7 into 9 is 63. To get an odd into even is actually always an even number, but if there is no even factor, it cannot be an even number. So the third statement is also true. And even into even is always even, because if you have an even number and you multiply it by any other number, it will always give you an even number. So 3 of the 4 statements are true. 9 is D. Question number 10. Prime factor decomposition of 2021 is this. What is the value of 53 into 57? We don't even need the first part of the thing. We can just simply do 53 into 57. Although they probably want us to use the first part, but let's just keep it this way. Simple fashioned long multiplication giving us the answer is D. 10 is D. 3021. Very simple question so far. Question 11. Question 11 was actually not that tricky of a question. Question 11, first we need to draw a Cartesian plane. And let's draw y is equal to 2x plus 3, which is roughly something like this. Probably a bit steeper, but something like that. Now let's start reflecting it across the x-axis. Let's look at this point. This would reflect here. This would reflect here. This would reflect here. This would reflect here. This would stay here. This would reflect here. And we would pretty much get a mirror image opposite, with this being minus 3. And the slope being exactly the same but negative. So 11 would be minus 2x minus 3, which is E. Y is equal to minus 2x minus 3. Nice question to check whether people are afraid of geometry or whether they can draw out the grid and actually understand what's going on. Question number 12. 40% of 50% of x equals 20% of 30% of y. Okay, so 40% of 50% is 20%, so 0.2x is equal to 20% of 30%, which is 6% of y, which is 0.06y. So you can just say 20x is equal to 6y, and y is equal to 10 over 3x. So 12 would also be E. Question number 13. Question 13 is, actually you don't even need to do it. So if you look at question 13, 1, 2, 3, 4, 5 has a factor of 3 because when you sum its digits, it's 15, and 15 by 3 is 15 is divisible by 3. So what happens is 15 is divisible by 3, so it has a factor of 3. And similarly, 5, 4, 3, 2, 1 also has a factor of 3. If you have two factors of 3, then you have a factor of 9. So what will happen is that this will have a factor of 9, so the remainder will be 0, so 13 would be A. Question number 14. A diagram shows a large square divided into squares of 3 different sizes. What percent of the large square is shaded? Alright, so what we need to look is, we can't find the medium-sized squares in terms of the larger and smaller squares. So we can try looking at the other way. So when we look at this image, when we make it a bit bigger, we can see that 3 of the medium-sized squares is equal to the length of 2 of the large squares. So one medium-sized square length is equal to, one large-sized square is equal to 1.5 squared medium-sized squares. So that would be 2.25 medium-sized squares. And there are 4 large squares in the center, which would imply 9 medium-sized squares in the center. So the center occupies 9 medium-sized squares. And of this, what would we say? We would say, let's look at the center only. Of the center, we can say 4 small squares is equal to 1 large square. So in total, the center has 16 small squares. So, and of those, 12 are shaded. So 9 into 12 over 16, or 3 over 4, is the total amount of medium-sized squares that would be shaded, which would be 6.75 medium-sized squares shaded. And we can also see the medium-sized squares on the outside are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16 squares on the outside. And of those, 3 to 5, 8 are shaded. So in total, we will have 14.75 over 25 squares. So we will have 59%, which is our final answer. So the answer to question number 14 is B. The key to this is to make them all in terms of one size of a square. Otherwise, you are definitely going to get tricked by this question, and you will get nowhere when you try to solve this question. Be sure to remember to get this into the same dimension. Alright, question number 15. Patrick drives from P to Q at 40 miles per hour. He drives back from Q to P at 45 miles per hour and takes 2 minutes less. So how far is it from P to Q? Alright, so let's say he takes X time to drive from P to Q. In hours, that is, because we're doing miles per hour and we don't want to convert that. Rather, we can convert minutes to hours. So 1 minute is 1/60th of an hour. So instead of x minus 2, we will write x minus 1/30th hours. Then we can do 40x is equal to 45x minus 3 over 2. And that means 5x is equal to 3 over 2. 3 over 2. X is equal to 3/10. And 3/10 into 40 is equal to 12. So question number 15 is actually D, 12 miles. Question number 16. Question number 16. Actually, this is we can first eliminate a few options already. So in question number 16, without even finding out this area of the semicircle, you can find out the area of the square in the center. 2 pi whole squared is 4 pi squared. So let's look at option A. Does it have a 4 pi squared term? No. So option A cannot be the answer. Option B, does it have a 4 pi squared answer? No. So option B also can't be the answer. Option C, does that have 4 pi squared answer? No, it has 4 pi cubed, but not 4 pi squared. Option C also can't be the answer. So it's option D, yes it does, and option E also has one. So it's between option D and option E. This is actually a very effective method of ruling out unnecessarily going through all the options over again. So we are left with option D and E. If you don't know how to solve the area of the semicircle, you already can have a 50-50 chance, which is much better than a 20% chance of getting this right. Alright, so now let's find the area of each of the semicircles. So we know the area of a circle is pi r squared, and the area of a semicircle is pi r squared into half. And we know the diameter of the semicircle is 2 pi, so the radius would be pi. So pi into pi squared into half is the area of one of these semicircles. So the area of one semicircle is pi cubed over 2, and you multiply that by 4 to get 2 pi cubed. Now if you look at both of the options, you can see that option D only has pi cubed, doesn't have 2 pi cubed. So you are left with only one option, which is option E. So 16 is option E. Question number 17. Question number 17 looks very scary when you look at the options. You can see some roots which you don't solve. So let's just draw out the figure. We need to draw a rectangle PQRS. such that PQ is the shorter side and QR is long, so obviously this has to be S. We also know this is 2, this is 4, and we know that there are points T and U such that these are equilateral triangles, so they all have side lengths of 2. So we need to find the area of quadrilateral QRUT, which is up till here. If we can find the length UT, since we know this is a trapezoid because it has parallel to a pair of parallel sides, we can actually solve the area of the trapezoid. So to find UT, we can simply do 4 minus the length of 4 minus the height of these two triangles. And the way to find the height of these two triangles would be to draw this perpendicular, draw 90 degree, drop a perpendicular, and you can see that this is 1 because this is half of the entire thing, and this is root 3. So in total, this length would be 4 minus 2 root 3. And given that we know UT is 4 minus 2 root 3, we can solve that the sum of this base and the other base is 8 minus 2 root 3. We can actually also solve the height. Because we know this is root 3, we can solve this is also 1. So the height is just 1. But we need to remember to divide this by 2. So we get 4 minus root 3, which is option D. You can actually back check this by seeing whether the sum of all the things in the rectangle is equal to 8. But we don't have that much time. I'll leave it up to you guys to check that. Question number 18. Just remember that in question number 18, they're bringing recurring decimals to trick you guys. But we all know if you just take the first 3 digits, it should be fine. So these are the first, let's say 4 digits for each of them. 1.0505, 0.9609, and 1.0400, and 0.9555. We can already see 0.9555 is too great and 1.0505 are far above. So, and we also know 0.9595 is smaller than 0.9609, so this also has to go. So we are left with 2 options, 0.9609 and 1.0400. When we look at this at first instinct, they look similar, but we can see that 0.9609 is slightly closer because the distance would actually be 0.0391, whereas the distance over here would be 0.04 something. So 0.039 is less than 0.04, so the answer would be C. So 18 is C. For this, you actually need to write out the first 4 to 5 digits. If you leave them as recurring decimals, you will definitely get confused. So my advice to you is to not leave them as recurring decimals. Alright, question number 19. Not too difficult. Come on, guys, we're near the end now. Alright, so this is the shaded area. This is Q, and the entire thing is P. The overlapped area is 1/4 of the entire figure's area. So we already know the area of the shaded figure is actually q squared, because this would also be q, and q into q is q squared, and that is equal to 1/4 of. So the entire area would be 2pq minus this thing in the center, so 2pq minus q squared. So q squared is equal to half pq minus 1/4 q squared. So 5/4 q squared is equal to half pq. And 5/2 q is equal to p. And then from there we can get 2p equals 5q, and p is to q equals 5 is to 2, so 19 would be A. Not too tricky of a question, I'm hoping. 4 is just A. Yeah. Alright. Question number 20. At first thought, you might get really tricked or scared because you see so many variables, and you might leave it. But actually, it's a very easy question. Perhaps I thought even the easiest question in the entire paper. Just need to know very simple arithmetic. So y is equal to px plus 4. We already know the values of x and y. The two lines meet at the point 3, 1, so we can substitute values. 1 is equal to 3p plus 4, giving us that p is equal to -1. From there, we can get negative, and we know y was 3, so -3 is equal to q into, -1 is equal to q into 3, so 3q minus 7, giving us 3q equals 6 and q equals 2. C, piece of cake. 20 is B. Question number 21. Question 21, actually, if you want to do it in a proper method, there is a way of doing it. But there's actually a shortcut to doing this question. You can just see that they're all square numbers, right? So the area of one entire, because this is, they are similar, because all equilateral triangles have the same angles, we can see that the area of the entire one hexagon has to also be a square number. And we can see that the areas already inside is 26 plus the middle hexagon. So 26 plus the hexagon must be a square number. We can try it for all the numbers, and we only got 38 as a plausible solution, so we already know 21 is D. But for those who want a more mathematical proof of this, let's actually find the side lengths of each of the smaller equilateral triangles. So in a equilateral triangle, if we have a side length A, then we can actually drop a perpendicular so that this is A by 2A, and we get this actually to be A root 3 over 2. And we also know that base into height over 2 is the area of a triangle, and we have the height, so A into A root 3 over 2 is the area. So A squared to root 3 over 4 is the area of a triangle, of an equilateral triangle. So from this we get A squared over root 3 over 4 is equal to 16. A squared is equal to 64 over root 3, and A is equal to 8 over root of root 3. Similarly, we can do that for the rest of them. So let's call the other side length B and the third side length C. B is equal to, so 4 squared is 16, and we got 8 as A is equal to 8 over root of root 3. So for the other one, it will be 6 over root of root 3, and C will be 2 over root of root 3. Summing all of these together will give us the side length of the larger triangle, which is 16 over root of root 3. and applying a squared into root 3 over 4 gives us 256 over 4 into root 3 over root 3, giving us 64. So the area is 64 of the larger equilateral triangle, and 64 minus 26 just gives us 38, so the answer is D. 21 is D. Both ways we have shown that 21 is D. Question number 22. At first sight, this might seem the most cumbersome problem on the paper, but it's actually such an easy question. I suggest looking at the two last terms first, because they look like one of the things I've seen in papers before, where they do 1 plus a into 1 minus a is equal to 1 minus a squared. But not quite, because they're not exactly like that. Let's just simplify this first. We get 1 plus plus 2 over x minus 1 minus 4 over x squared minus 1 minus 2 over x plus 1. And we need to multiply this by, what is it? 1 plus 1 over x. So this whole thing into 1 plus 1 over x. Sorry, we don't have much space. Let's just get rid of the top part. The beauty behind this is, let's take the common denominator x squared minus 1 in the top part. So we get x squared minus 1 and plus 2x 2x minus 2, 2x plus 2, and then we get minus 4 minus 2 into x minus 1, so we get minus 2x plus 2, the whole thing over x squared minus 1, and that is into 1 plus 1 over x. When we simplify this, we can see 2x and 2x cross off, 2 and 4 cross off, leaving us with x squared minus 1 over x squared minus 1, which is just 1. So we have, actually, this simplifies to 1 plus 1 over x, which is equal to x plus 1 whole over x, which is option E. This is actually a very elegant solution to such a tricky problem, which could have 8 parts if you don't know how to simplify this properly. But if you try to see a pattern between them, it actually just results in a very fast solution. Question number 23. All right. Question number 23. So, towards the end of the paper, don't give up hope and keep trying on, even if you couldn't get some of the past few questions. Just keep moving on, and at the end of the paper, come back to the questions which you could not get. So, this is our figure. And from what we can already see, there is one semicircle, but this figure which is shaded also somewhat looks like a semicircle, but it isn't exactly a semicircle. So what we do know is this is a quarter circle OQR and POR. And if we construct a line PR, then actually this is also a semicircle right over here. Around the edge, this is actually a semicircle. So, and this is a triangle, a right angle triangle, where we know PO is 2 and OR is 2 because they're both radii of the semicircle, quarter circle or semicircle. So, first we can find the area of the triangle. So the area of the triangle is simply 2, because 2 into 2 over 2, so this is 2. And the area of the semicircle is actually pi r squared over 4, where r is 2, so pi into 4 over 4, which would be pi. So this leaf right over here actually has an area of pi minus 2. This helps us because we can find the area of the shaded figure by subtracting the area of a semicircle minus pi minus 2. So we know that this length, PR, is 2 root 2 through Pythagoras theorem. 2 squared plus 2 squared equals PR squared. PR squared equals 8, so PR equals 2 root 2. So PR equals 2 root 2. So the radius of that semicircle is root 2. So pi r squared over 2 gives us 2 pi over 2, which means the area of that semicircle is pi. And you do minus pi minus 2 to get the area of the shaded region, which gives us the area of the shaded region is actually just 2. So 23 is B, which is 2. This is actually just requires you to know one simple thing, that you need to construct a line over there to split it into a triangle and a semicircle. I've actually come over a few of these problems before, but don't worry if you could not get this, because this is not a very easy question. So now we move on to question number 24. Question 24. Sam writes on a whiteboard the numbers 1 to 6, and he writes P additional 5s and Q additional 7s. The mean of all the numbers is 5.3. What is the smallest possible value of Q? Alright, so the sum of the numbers 1 to 6 is 21, which is 6 into 7 over 2. And he writes P additional 5, so 5P plus 7Q over 6 plus P plus Q is equal to 5.3. That's the way you calculate the mean. So you get 21 plus 5P plus 7Q is equal to 31.8 plus 5.3P plus 5.3Q. Let's just cross this off. That gives us 1.7Q minus 0.3P is equal to 10.8. So 17Q minus 0.3P is equal to 108. Minus 3P is equal to 108. So from what we can already see, since P can't be negative and Q can't be negative, Q has to already be greater than 6. So Q has to be at least 7. So let's start with Q equals 7. If Q equals 7, 17Q is 119. 119 minus 108 is 11, which is not a multiple of 3. Hence, 7 is not possible. Then let's go with 9. 17 into 9 is 153. Minus 108 is 45, which is actually a multiple of 3. So 9 is the smallest value for Q, which means 24 is B. Question 25. Question 25. Finally, the last question of the paper. I'm sure you guys are exhausted. Hang on. We're getting there. Alright, so when a down escalator is moving, Thomas can run it down in 15 or walk it in 30 seconds. One day when the escalator was broken, he could run down the escalator in 20 seconds. How long would it take for Thomas to walk down the broken escalator? So, let's say he takes X seconds to walk down a stationary escalator. So that's 1 over X. And the speed of the escalator is y. The time it takes for him to walk down the escalator is y. So 1 over y would be his time taken, and eventually that is equal to 1 over 15. Similarly, 1 over z, which is let's say his walking speed is plus 1 over y is equal to 1 over 30. And we know 1 over x is 1 over 20. So 1 over 20 plus 1 over y equals 1 over 15. So y is equal to 60. So you got 1 over z plus 1 over y is equal to 1 over 30. So 1 over z equals 1 over 60. Z is also equal to 60. So on a broken escalator by himself, it would take Thomas 60 seconds to walk down. So 25 is E. So finally, we have come to the conclusion of the 2021 IMC Cayley paper. For the last question, remember, their method is very tricky. This method actually comes from an Indian mathematics book, and you just do 1 over x plus 1 over y is equal to 1 over 15, or the total time taken for him to run down plus the escalator, and 1 over y plus 1 over z equals 1 over 30. So, and we know that given 3 equations, 3 variables, we can solve it. So that's how we get our answer 60 for the last question. So I'm hoping you enjoyed this paper. Be sure to like and subscribe if you want to see more such videos on UKMT and other mathematics problems. And you can take a screenshot of the answers and compare it with the answers you got. I hope you enjoyed this video, and be sure to like and subscribe. Thanks. Bye.